two sketches as a summary as to what we have so far, because that will lead us into the next part of the work. The next part of the work that we're going to do is we are going to do the equation of the tangent. So I'm going to give you the graph and I'm going to ask you find the equation of the tangent at, let's say, x is equal to 2. So this is as a little recap, but also leading into that work. So if we have the graph of a cubic function with a bigger than 0, met ander woorde, let's say that's my graph, and you all agree that for this graph, a is bigger than 0. Yeah? Okay. How do I find this point on my graph? What is that? It's the y-intercept, so I set x equal to 0. I'm all back. Another thing that we've done thus far is getting the x-intercepts. So you all know to find the x-intercepts, what do I do? I set y equal to 0, and that's the new skill for factorization of a cubic function that we did last week. So om die x-afsnitte te kry, stel jy y gelyk aan 0 en dan doen jy daai wat jy eers jou sakrekenaar gebruik om die eerste hakie te kry en dan daai A B C dingetjie doen om die tweede hakie te kry. Everyone with me? Okay. Then we did the turning points, also known as the stationary points. So that's these ones. Nope. Okay. Hoe kry ons die stationêre punte of die draaipunte? How do we get the stationary points or the turning points? We must have other. We say first derivative equal to 0. Inverse is nou die dag se werk. Okay. Dan so 'n stuk van die werk wat ons nie spesifiek so behandel het nie, maar ek dink julle sal dit redelik maklik kry. Stem julle saam vir hierdie deel van die grafiek is hy stygend. Which means that will be bigger than 0. I'll show that to you today as well. But do you guys agree that dit is mos die gradiënt? Né? En met ander woorde, as ek nou 'n reguit lyn hier gaan trek, dan gaan daai reguit lyn 'n positiewe gradiënt hê, want dit is 'n stygende lyn. Do you guys see that? So the first derivative will be positive for those values. For these values, it will be descending. Wat beteken die eerste afgeleide gaan kleiner wees as 0. So if I draw a tangent to the graph for that interval, the tangent will have a negative gradient. So die eerste afgeleide is negatief. And then here it is ascending again. Wat beteken die eerste afgeleide is groter as 0. Okay, en die rede hoekom ek gou daarby wil stil staan is julle gaan sien wanneer ons nou begin om die raaklyne te teken, sal hulle partykeer vir jou sê bepaal die gradiënt van die raaklyn aan hierdie kromme by x gelyk aan 2. And then they'll ask you to comment on the shape of the graph at x is equal to 2. Then you have to say, okay, because the first derivative was a positive value at x equal to 2, that means that the graph must be ascending. Okay, so as die eerste afgeleide vir jou positiewe waarde gee, beteken dit die gradiënt is stygend, so die grafiek is stygend. En as die eerste afgeleide vir jou 'n negatiewe waarde gee, then it means the graph must be descending because the tangent will be a negative gradient. Okay. Goed. Nou die een waaroor ons nou die dag gepraat het. And that is the point of inflection. And how do we get that? Second derivative equal to 0. So sien julle ons het elke keer of gelyk aan 0 of groter as 0 of kleiner as 0. You see that? We either have equal to 0, bigger than 0, or smaller than 0. Whenever it is equal to 0, it is either changing form in the sense of changing from ascending to descending or the other way around, or it is changing concavity. So changing from convex upwards to convex downwards or the other way around. So oral waar ons 'n afgeleide of 'n tweede afgeleide gelykstel aan 0, verander die vorm van die grafiek of in terme van stygend en dalend of in terme van die konkaviteit van die grafiek. Ja. Almal van julle by. Okay, so on this side, wie van julle kan onthou hoe is sy vorm as hy lyk soos 'n negatiewe parabool? It's concave downwards. Okay, think negative parabola down. And you have to know that that means that the second derivative will be negative. So die tweede afgeleide, as ons hom vir enige waarde van x aan die linkerkant van die punt van infleksie gaan kry, gaan dit vir my 'n negatiewe antwoord gee. And on this side, you guys see it looks like a positive parabola. Yes, Lauren? They'll ask you to comment on the concavity of the graph. If they're asking for form or shape, they're asking for ascending or descending. If they're asking for concavity, that is the only time you look at the second derivative. Okay. Another way that they can ask it is, let's say they ask you to determine the point of inflection. So hulle het vir jou gevra om die buigpunt te kry. En dan sal hulle vir jou vra wat gebeur by die buigpunt. So then you have to say it changes from concave downwards to concave upwards. Okay. Goed, so vir daai stukkie wat dit lyk soos 'n positiewe parabool, is hy meaning that the second derivative will be positive. Okay. What I'm going to show you guys tomorrow is how we can represent all of this graphically. So you don't have to draw this. But if my original function, because tomorrow I'm going to do it with an actual example. I don't think we'll get time today. Is 'n cubic graph. Met ander woorde, hy het daai twee draaipunte. Dan gaan sy afgeleide 'n parabool wees. Do you guys agree that that will be a parabola? Okay, and what you will see tomorrow is that the x values of this turning point and this turning point. Ek wil eintlik teken dat hulle nie op die as se draai nie. Those two x values will coincide with the x-intercepts of the parabola. Why? Because the parabola is the first derivative of the cubic function. And where I set a parabola equal to 0, I get the x-intercepts. So graphically, that is what you are doing. Die afgeleide van die derde graadse funksie is 'n parabool. And then if you get the second derivative, that's a straight line. Sien julle dis 'n reguit lyn? En sy x-afsnit gaan ooreenstem met die draaipunt van die parabool sowel as die punt van infleksie van die derde graadse funksie. So it all comes together because it steps down a degree each time. So hy sal sê nou maar so lyk. Maar gaan môre vir julle die actual soos 'n actual derde graadse funksie teken en dan gaan julle saam met my sy afgeleide kry wat 'n parabool is. En julle weet mos hoe om 'n parabool te teken. So we're going to do that. Yes, you know. And then we're going to draw the parabola with its turning point, with its x-intercepts and everything, and you're going to see that the x values of the one coincides with the x values of the other one. Do you have a question, Lauren?
Will they ever combine the inverse functions, for example, the amount with the
No. Okay. The only times that they will ask you inverse of anything else except for not inverse, sorry, derivatives combined with any other graph except for a cubic function or parabola is in those theory questions where you just have to use the rules to get the first derivative. So net daai wat ons mos gesê het, jy verwyder die hakkies of jy haal die wortelvorm weg of so iets. And then you guys will see in the exercise that we're doing now, they do a hyperbole, but the only thing that they ask you is the graph ascending or descending. So hulle gaan nie vir jou vra om die kombinasies dan te teken nie. Ons teken net die derde graadse funksie en die parabool. What they can do is they can give you the parabola, tell you this is the function of the first derivative, and you have to work back to the original function. Yo. But we get there. Okay. Good. But if we look at this, ek gaan nou nie die ene ook teken nie. Do you guys see that everywhere where this one is ascending, that one will be descending? And at the point of inflection, it changes from concave downwards to concave upwards. So, maar al daai afgeleide is groter as 0, kleiner as 0 en so reverse nou net hierso basies. Okay. So from this, kom ons begin